Alright, here we're going to look at some properties of logarithms in section 6.6. So, ever wonder how safe the pool you swim in is during the summer? A pH balance is determined from hydrogen ions, that's a science term. A neutral pH is 7. So if you're familiar with the pH scale, 7 is right in the middle, which would be, pure water or distilled water. And then lower numbers are acidic, so it goes down to 1, which is the strongest acid you could have. And it also goes up to 14, which is the strongest base that you could have. And if you just Google image pH scale, it'll tell you some of the different things that fall in the different categories. And when you get to either end of the spectrum, a very strong acid is very harmful, but so is a very strong base. Bleach is a base. The bleach is certainly harmful. It has its uses. And then things that are acidic, tomatoes, lemons, like lemon juice is acidic. And there's all sorts of things in between. And you can see where they land on the scale if you just Google image pH scale. Now, the pH scale is logarithmic, just like the earthquake scale was that we watched in the previous video, which means if I go to 8 or to 6, and it kind of goes both ways to where you won't really be comparing like this 8 and 6 as much because it's from the base scale and the acid scale, but more so looking at, as you get further down in the acid direction, going from a 7 to a 6, it's logarithmic, so it's 10 times as bad. So if you go to 5 on the scale, 5 is 10 times as bad as 6, or it's 100 times as bad as 7. So it's the logarithmic scale to where we're able to keep the pH scale from 1 to 14, 7 being neutral, but where each rung up that you take gets a lot more potent very quickly. So we're going to look at, eventually by the end of this lesson, what's the difference in pH within a swimming pool compared to a pool of lemon juice. And we'll see, how much more acidic it is. Now, something else, and I don't want to get too sciencey with this because I'm certainly not a science expert, but things on the pH scale doesn't necessarily mean that it's harmful to touch. Some soaps and shampoos are bases, and they're stronger bases than some other types of things, but they certainly don't hurt us. They serve purposes. And it's not saying that if you put lemon juice on your hand, it's going to sizzle your hand away like you think of when you think of acid, or maybe battery acid. Determining if something's going to react negatively and harm your skin is more so a chemical reaction than where it ranks on the pH scale. You probably could get into a pool of lemon juice. You wouldn't want to open your eyes in it, and it would burn if you had cuts. But lemon juice isn't something that gets on our skin and sizzles like a traditional acid. That's more of a reaction rather than the pH scale. But the pH scale from a science perspective is just a scale that tells you how potent something is, either as a base or an acid. Before we get there, though, we're going to look at some properties of logarithms. And we'll use these a lot. So these are important. We'll need them for future sections. We'll use them when we're solving logarithmic equations. So don't write these off. They're also fairly simple and straightforward after you practice them just a little bit. So here's the first scenario. What we would do if we've got some log base b, could be 10, who knows, and we've got two things. We've got an m times an n, both occurring at the same time. You can split that up into the log base b of m plus the log base b of n. So one of the properties is if you have two things that are multiplying, you split them up into two pieces where they are adding. The next rule is if you've got two terms that are dividing, you'll split them up into the two terms once again, and you could probably guess, based upon opposites, what sign's going to be in between them. because up top we were multiplying, it corresponded with addition. Now we're dividing, it indeed corresponds to subtracting. So that's one of the other properties. If you have two terms that are dividing within a logarithm, you can split it up to subtraction. And then there's one called the power property. This one's a little bit different. This is if you have an exponent within the logarithm, it can move out front. So this one is definitely different than the others, right? You can see that that exponent can go out front. It doesn't follow the same type of pattern as up above. In the proof or the description of why that rule is, you could look that one up. It uses some more complicated properties of logarithms to solve it. And you don't have to know why that rule works. Just understand that if you have an exponent within the logarithm, he can come out front and be a multiplication number out front. So we're going to apply this concept to some of these here. And the reason that we use properties of logarithms is to help us answer scenarios that would have originally needed a calculator. So log base 3 of 54 minus log base 3 of 2. That's one of the properties we saw up above, to where if it's subtraction within two logarithms, I can set that up to be division. And 54 divided by 2 is 27. And if you're very familiar with how logarithms work, you might already know what the answer to this is. And if we do a loop and swoop, this is answer equal to something. This is 3 to the something power is equal to 27. And that answer is 3, because 3 to the third power is equal to 27. So what that means is that this whole concept is equal to a 3. If you tried to type this in on your calculator, you'd get a big decimal, you'd get another big decimal. They would subtract out to 3. I'm also going to show you on today's lesson how to type that in on your calculator. If the base down here is something other than 10, it's a little bit more tricky than you might think. But we don't need to do that yet anyways, because we're learning how to simplify logarithms by just using properties of logarithms. So here we've got one. We're not going to solve it because it's variables, but we're going to condense it down. If there's a number out in front, that means it can go be an exponent. So the first piece of this is to rewrite this as log base 2 of x to the 6th power plus log base 2 of y to the 5th power. And then using the above properties, we could condense this down to log base 2 of x to the 6th multiplied by y to the 5th. So all we're doing right now with the properties is just switching things around from being in multiple pieces, like this one. It was multiple pieces that we shrunk down into one piece. And other times, 2 will be given multiple pieces, and we can shrink it down. So that's going one way through the rules. You can also go the other direction where you're asked to expand. Now, recall when there's no base, if you don't see a number there, it's an invisible 10. What we have to recognize is that we've got multiplication going on here, and we've got a division going on here. I do want to go ahead and be, clear on this example because people get very confused. Multiplication and division, because here's multiplication, here is division, can occur in any order. People often get really confused on this, and they'll say, Mr. Cottle, how am I going to do this because there's kind of 3 things going on at once? When you recognize that there's 3 things going on at once, that is good, because that means we're actually going to need 3 different log pieces. All right, and you could actually do this in any order you want. I'm going to go ahead and do this up top part first, which was log base 10 of 4 times the x. Whenever I'm using multiplication, that really means to use addition. All right, so this circled part, that 4x, split up into addition of log 4 and log x. And then the division of y. Division meant subtraction. So I'm going to put subtract log of y. However, the order doesn't technically matter. So this is a valid answer. You also could have, if you wanted to, you could have put the minus log y out front if you wanted. It doesn't matter as long as the negative sign is with the y, because the y was the one that was division. But I want to clear that up because sometimes people think that they need to do all sorts of weird things, such as group up some of these and have like more fractions and denominators. You just split them up in as many pieces as necessary. If they were multiplying, they get a plus sign. If they were in the denominator, they get a subtraction sign. So, checking this one out, I see we've got multiplication. So I could do log base invisible 10 of x to the third plus log base 10 of y to the fifth, and then use the property to where if I have an exponent inside the logarithm, we can move it out front. So this would be 3 log of x plus 5 log of y. And then one more here. We've got log base 4 of 5 times square root of x. And the reason I put this one on here is just to help us remember that anytime you're underneath the square root, it's the same thing as the 1/2 power. So I'm going to need to first get my two pieces set up here, one of them being log base 4 of 5, plus, because it was multiplication of the 5 and x, log base 4 of x to the 1/2 power. And then anytime we have an exponent, we can move it out front. So this final answer would be log base 4 of 5 plus 1/2 log base 4 of x. So until we start to solve equations with these properties, it'll essentially just be kind of math that you're doing for no reason. But we'll get there. We'll start to use them to solve things coming up in the later sections. But it's all about just expanding or contracting. And once you do a handful of these, and the homework has plenty for you to try with the answer keys, you'll see that hopefully that this isn't too bad using the properties of logarithms to expand them out. The only reason that people struggle with them is just because they see that word log and they freak out. But don't freak out. Just follow the rules and the properties, follow your guidance and practice that you've done, and you'll be fine. So let's talk about something called the change of base formula. This is starting to become less important now that we have newer calculators with fancy buttons. But it's important anyways. Now, if you look on your calculator, I'm going to draw a little calculator here. The fourth button up, so 1, 2, 3, 4. This button up all the way to the left says log. But you don't see a base, and that's because that button assumes you want log base 10. But if I gave you something like this, log base 4 of 18, your calculator doesn't have a button for that on its own. And what we would use to solve for that is instead something called the change of base formula. And it looks like this. And I left here to where it says C is usually 10 but can be whatever. We're essentially going to, if we had a scenario where we have a base that's not 10, re-express it in base 10. And you do that by putting log of the number up top divided by log of the number on the bottom. And if you're curious about what these C's are, they're going to be base 10s. That way we can use the button on our calculator. So if I wanted to type this in on my calculator using that log button, I'd need to type it like this. I want to first open up a parenthesis, and I'd say log of 18. I'm going to close that parenthesis, push the division button, open up another set of parentheses, and it's going to actually put this 18 in parentheses like that too. We'll divide it by log of 4, like that. And it would give me an answer, and you can try it on your calculator to where if you type that in, and I put more parentheses than you technically need, I just want to make sure that it works correctly for everyone. You should get 2.08, and then it goes on and on. All right, so that's the method that everyone used to do, called the change of base formula. However, if you have the newer calculators, there is a shortcut, and that shortcut is the alpha button. Right, and alpha, if we're talking about our calculators here, here's the big screen, right? You've got your y equals button, you've got your second button, and then there is alpha. So if you push alpha, and then you push the window button, which is right here, so let me get a highlighter tool. So that is window. If you push alpha window and you have the newer calculators, a list will pop up. And in that list, you have a whole bunch of different math stuff that we can do. Most of it's calculus. But you'll see that option 5 then lists for you something called log base. And if you hit enter on that log base, you'll get this. Log with a little square, and then a square there. And then you can type it in straight up. So I could type in more quickly log base 4 of 18. Right, so go through and use the alpha window version, log 4 of 18, and you'll get the same answer of 2.08, whole bunch of stuff. Right, but you can see that both ways work. The calculators now, a few years ago, I guess it's been about 10, have added that in to where we don't have to use the change of base formula anymore. But not everybody's calculator will have it, so you can do it as such. Log of the top number divided by log of the base, using this log button right there, which assumes you want log base 10. So you won't have to use alpha window if the log you're trying to calculate is base 10. And then one more final thing before we move on. If you're forgetting what logs are, log base 4 of 18 is asking 4 to what power? Right, 4 to what power gives me 18? And the answer is that. And that should make sense because 4 squared is 16. So 4 to the 2 point and a little bit more gives us the 18. That's what logarithms help us do. And we're getting closer to being able to solve, and you could probably do it right now, but we're getting closer to scenarios where I could give you something like log base 5 of 17. You would now be able to figure out what exponent 5 needs to be raised to. So you could tell me 5 to what power gives me 17 now by typing that in. We'll explore that more in its own lesson. All right, so it says remember yesterday is a problem that we had previously skipped. And I skipped it because it was something from an older style of methods. But essentially now we can solve things like this very quickly. All right, so either using your change of base method or your alpha window, make sure that you can reach the answer here of, and when I type this in, I get 1.666, and it's actually repeating. So I'm going to go ahead and hit math, and then enter, which is our old friend to turn decimals into fractions. You would get an answer of 5 over 3. Sometimes these answers will have fraction answers. This one does. This one that we previously did does not. If you go back and try log base 4 of 18 and get that 2.08, and you try math enter on it, it'll stay like that. Sometimes these answers are irrational, which means they're decimals that never end or repeat. Sometimes they're fractions. So you can always use math enter to double check if it's going to be a fraction or not. All right, so let's use our calculators in practice. Find the answer to these different logarithms using the change of base method or the alpha windows, with option 5 being log base, and then try math enter. I will say that this one is going to be a fraction. This one's not going to be a fraction. This one's going to be a decimal. And this one is also going to be a decimal. So on this one, be sure to use math enter and try it for these two as well. You'll just see that it doesn't work. So I'll give you a moment. Pause this video, because when you push play again, it's going to show the answers. Pause this video and make sure that you can find the values of those different logarithms. And here are the answers that I got when I went through and used my calculator to find the different answers. And once again, I encourage you, so that we don't lose sight of what logarithms are, is asking you, so this one is 3 to what power gives me 6? I know it's going to be less than 2, because 3 squared gives me 9, and that's why I get a number that's a little bit less than 9. 3 to the 1.63 power, approximately, would give me 6. On this one, 2 to the 1.58 power gives me 3. So now let's go back to the pool of lemons. So the pH of any substance can be found through, and then this equation, which is negative log base 10 of the positive hydrogen ions, where the positive hydrogen ions are the hydrogen ions in a substance. That's all science stuff. I maybe at one point understood it, but I don't remember it now. I did look up, though. Lemons have an acidity of 2.27, which is very high. You remember that scale starts at a neutral of 7. 1 is the strongest acid. 14 is the strongest base. So chlorine water is actually a base. It's a little bit more of a base than plain water. But, it's very close to 7 still, because the swimming pool is almost all water, plus a little bit of the chlorine. So chlorine's a higher base. But when you mix it with all that pool water, you get something around 7.4. But that's why pools will often check the chlorine levels to make sure it's not getting too far away from 7. You want to keep it in the right range to kill all the germs, but you don't want it to be harmful for people to swim in. Meanwhile, lemons are all the way down here, very acidic. Doesn't mean they're going to burn through your skin or burn through your carpet if you drop it on your house. It's just a level of hydrogen ions that they have. All right. So this formula looks a little fancy. And so ultimately what I did here for us is I found the answer to the number of hydrogen ions that are in lemons. And this amount right here corresponds to that pH scale of 2.27. Right? And then the pH level of the pool corresponds to the 7.4. All right. And those 2.27 and 7.4 is what you would get when you use the formula. And I had to look all this up, but I just wanted to give you an example of pH scales. And so I set it up 2 different times. This here is the formula to determine the pH of lemons. So then I'm going to subtract it because I want to find the difference. This formula here allows us to find the pH of the chlorine water. And so I encourage you to type this in, negative log, so put a negative sign out in front. You can actually just push the log button on this because it's base 10. And then 5.4 times 10 to the negative 3 power. And after you round, you'll get 2.27. So we'll subtract that from, and then on this one here, we've got the answer of 7.4. And when I subtract those two together, we get a difference of 5.13. And yeah, it'd be negative, but we're just talking about how far away they are from each other on the pH scale. So what that means with 7 being neutral, and then we had the pool water here at 7.4. We have the lemon juice down here at the 2.27. They are very far away from each other. And with this being a logarithm scale, what this actually tells us is that when I do 10 to the 5.13 power, these are 134,896, levels of intensity apart. Because logarithm scales, are in base 10, so 10 to that power gives me that answer. What that means is that, swimming in lemon juice and swimming in chlorine would have drastically different effects if you were to, let's just talk about opening your eyes underneath the water. You can open your eyes up in chlorine water. It might hurt a little bit, but you can certainly do it. However, if you try to open it in lemon juice, it's going to hurt very, very badly because of the amount of difference they have in pH. Lemon juice is high up on the pH scale, so it's going to burn, it's going to sting. So just like if you get into a pool and you have a cut, sometimes it might burn a little bit. It would burn much more in lemon juice because it's a higher acidic count. Do not try to swim in lemon juice. I have not run an experiment to find out if it actually hurts you or not. I don't think you'd be able to get enough lemons to pull it off, but I'm not sure. I don't want anybody getting lemon juice hurt because of its acidity count. But it's fun to look at and just understand some examples of where scales use the pH scale in math.